Hey everyone and welcome back to the channel. In today's tutorial, we are going to build a complete sales analysis dashboard using Python, Pandas and Matplotlib. Before we start coding, let me quickly show you what the final output will look like. Once the script is executed, it automatically generates 4 visual charts, including sales by product, sales by region, and monthly sales trends. Along with that, the project will also save the monthly sales CSV file, the sales by region CSV file, and the sales by product CSV file. You will also see that our bar chart is exported and saved automatically in the project folder. So that's the final result we are working toward in this tutorial. Now let's begin building this step by step. I will first create a new Python project and name it sales underscore analysis underscore dashboard.py. And now I will be completing this entire project in 10 simple steps. So let's begin with the step number 1, that is importing the required libraries. I will add this as a comment in the code and then start importing our libraries. First I am importing Pandas as PD. Pandas is a powerful library that helps us handle, clean and analyze structured data. Next I am importing Matplotlib.pyplot as PLT. This will allow us to create all kind of visual charts throughout the project. And finally I am importing Seaborn as SNS. Seaborn is built on top of Matplotlib and help us create more visually appealing and modern looking charts. So that complete the step number 1, and now let's move on to the step number 2, that is loading the CSV file. And as you can see, this is our raw CSV file, that is sales underscore data.csv, which contains all our sales records. I am going to open my file explorer and then I will copy the path where the CSV file is saved. Then inside the code I will create a variable called file underscore path. Write the opening R for a raw string and paste the path inside quotation marks. After that, I will also type the file name itself, sales underscore data.csv, at the end of the path. Now that our file path is ready, I will load the CSV file by writing df is equal to pd.read underscore csv, and inside of the parentheses I will be writing file underscore path. This reads the data and stores it inside a data frame called df. And that complete our step number 2. And now let's move on to the step number 3, that is displaying the original data. By this I simply mean that we are going to preview the first few rows, check the data types and look at the statistical summary of our dataset. So I have added this as a comment in the code, and now I will display the first few rows by using the df.head. Next, I will check the data types and overall structure of the data frame by using the df.info, and finally I will view the statistical summary using df.describe. Now if I run the program, you can see the output here on the screen, and if I also open the raw CSV file side by side, you will notice that the first 5 rows displayed in the terminal match the first 5 rows in the actual dataset. Our columns include date, product, region, sales and quantity. And from the df.info output, you can clearly see that the date column has all 9 entries, which means there are no missing values there. But the product column has 8 non-null entries, meaning one entry is missing, and the same goes for the region column and the remaining fields. Each of them has 8 values and one missing value. Then we have the statistical summary from df.describe. Since sales and quantity are our numerical columns, the summary shows useful statistics like count, minimum, maximum values, mean, standard deviation, and percentiles, etc. for these. So that complete our step number 3, where we analyzed and understood the structure of our raw data. And now let's move on to the step number 4, which is checking the missing values in our dataset. For this I am using command df.isNull.sum. This gives us the total number of missing entries in each column. When I run the program, you can clearly see that the date column has no missing values. All entries are present, but the product, region, sales and quantity columns, each of them has exactly one missing value, which exactly matches with our raw CSV file. So that's complete our step number 4, and now let's move on to the step number 5, which is cleaning the missing values. So basically we will be doing here two tasks. The first one is fill missing numerical values, right? And the second task is going to be fill missing categorical values. And I have added both of these as a comment in the code, right? In our dataset, the numeric columns are sales and quantity, right? While the categorical columns are region and product. Let's start with the numeric ones first. I have listed the numeric columns inside a list. So I will be using a list, and inside of it I will be writing the name of the numeric columns that are sales and quantity, right? And then I am using a simple for loop to go through each column. Inside the loop, I am checking whether the column exists in the data frame, and if it does, I am filling any missing value with 0. Now next I am handling the categorical columns. I simply copied the same loop and replaced the numeric list with the categorical list. So instead of numeric stuff, I will be replacing those by the categorical stuff. And those includes these columns as well, and these are region and product, right? I am filling the missing entries with the string unknown because these values represent categories and not numbers. In order to verify that everything has been filled correctly, I am printing the missing values again using df.isNull.sum again, right? So I will use here a print statement. I will copy this print statement of rechecking and paste it over here, and instead of rechecking, I will be calling it as checking. And now if I run the program, as you can see it from here, before we have one entry missing, but after cleaning, all columns shows 0 missing values, which means our data is now complete and ready for further processing. And that complete our step number 5, and now let's move on to the step number 6, which is removing duplicated rows and converting the date column into the correct format. I have added this step as a comment in the code. To remove duplicates, I am using df.drop_duplicate in place is equal to true. Setting in place is equal to 2 ensures that the duplicates are removed directly from the data frame without needing to create a new one. And next we need to make sure that our date column is in proper datetime format. For that I am using pd.to_datetime. And here parameter error is equal to queries means that if pandas encounter any invalid or incorrectly formatted date, it will convert them into NAT, not a time basically, instead of causing an error. After that I am printing a message after removing duplicates and date conversion. And then I will be calling the same three commands df.head, df.info and df.describe to check the updated result. And I will run the program. As you can see on the screen, any duplicate rows have now been removed and the date column has been successfully converted into a proper datetime format. And this basically completes our step number 6, and now let's move on to the step number 7, where we calculate total sales for each product. So I will be writing here as comment total sales per product. There are two tasks in this step. The first is grouping the data by product, right? And the second task is displaying the top 5 best selling products. So first I will be doing the task 1, that is group data by product. I am creating here a new variable called sales underscore per underscore product, and then I will be using here df.group by product. That will basically group the rows based on product names, and then I will be using sales.sum. That will calculate the total sales for each product, and finally dot sort underscore values ascending is equal to false, which basically sorts the results from highest to lowest, right? Then with a simple print statement I will display the result, right? In the print statement I will be calling sales per product here. If I run the program, And as you can see it from here, product B has the highest total sales at 1950, followed by product C at 600, and so on. The products are displayed in descending order based on sales. So here we are done with our first task, and now let's move on to our second task, that is top selling products. I am creating here a new variable top underscore sales, and I will using sale per product dot head 5. So head 5 function simply picks the first 5 values from our already sorted list. We have sorted that list in our task 1, and this is our current task 2. I will display the result here by using this print statement, and if I run this program, and as you can see, it displays the top 5 best selling products along with their total sales. And that basically completes our step number 7, and now let's move on to the step number 8, where we will calculate total sales per region and also analyze the monthly sales trends. And I have written both tasks as comment in the code. So first I will be doing the task number 1, that is total sales per region. For this I simply copied the same grouping logic we used earlier in step 7, but now instead of grouping by product, I am grouping by region. And this will basically give us the total sales for each region and arrange them from highest to lowest. Next, I will calculate the monthly trend, which means finding out how much total sales were made in each month, right? To do that, I first create a new column for the month by writing df month is equal to df date dot dt to period m. What this does is extract only the year and month from date column. And then I reuse the grouping logic again, this time grouping by month column, right? And I will here basically replace it with month so that the monthly data can be displayed over here. So I will make here some changes, and here as well, instead of product it is region, and this is dt2 period, right? And if I run the program, you can see that the output displays the total sales for each region first, and then directly below that it shows the monthly sales trend. Both results match the data from our raw CSV file. So that complete basically our step number 8. Now we move on to the step number 9, which is one of the most important sections, that is data visualization. And in this step we will generate 4 different sections of charts using Matplotlib and Seaborn so that we can visually understand our sales trends. So I have added this as a comment. So first I will start by setting a clean white background using sns.set underscore style white grid. Then I have to create here a bar chart sales per product, right? So I've added here a comment, and we have learned what is sales per product here in this section as well. This is in step number 7. So first thing I'm doing here is writing plt.figure. Inside this function I need to define the size of the figure. So I'm using fig size is equal to 10,6. This simply means that the width of the chart will be 10 units and height of the charts will be 6 units, giving us a clean and readable layout. Next I'm using Seaborn's bar plot function. And here I have to define 3 main things: the x-axis labels, the y-axis values, and the color scheme of the bars, right? So these are basically the 3 main parameters for sns.barplot. And after that I will be writing here plt.title. So it is going to be sales per product, and it will basically sets the title of the chart. And then I will be writing plt.x label, and this is the basically label for the x-axis. It should be product, and for y-axis it should be sales. And then x ticks, it will basically rotate the x-axis label by 45 degree for better readability. And plt.title layout, this basically will adjust the spacing so labels and the title fit neatly inside of the figure. And plt.show will simply display the chart on the screen. And now if I run the program, you will be able to see this figure. and the title is sales per product. You are able to see the X label, the Y label, the values on the Y axis, etc. And now let's move on to the second chart. Now this chart is going to be almost exactly the same as the previous one, so I will copy the first one and paste it over here, and I will simply replace product with region. I will make those changes from here as well. The title is going to be region, X title is going to be region, Y title is going to be the same. I can change the size of this figure and the rotation as well. And as you can see, this is our second chart, sales per product, right? And now let's move on to the third one. So basically I'm going to copy the second one and paste it over for the third one. So this is going to be for monthly trend, and this will be a line chart. So I will make here some changes. I have already written here the code for the monthly trend. So I will basically here changing the second line, and that is going to be monthly underscore sales dot plot. Kind is equal to line means create a line chart to show trend over time, right? And then moving on to our fourth chart, that is going to be a pie chart, and that is for top 5 selling products. So first I need to define the figure size, and that is going to be 7,7, and it will create a square figure for a balanced pie chart. And then on the second line I'm writing plt.py. Top underscore sales dot values will basically show the sale of the top 5 products, and top underscore sales dot index adds product name to each slice. Auto PCT 1.1 basically display the percentage contribution of each product on the chart, and start angle is equal to 140, basically rotate the chart for better readability. Plt.table will basically adds a reference table, and plt.show will display the pie chart. And if I run the program, as you can see, we will be able to see 4 different figures over here, and the last one is the pie chart, this one. And finally moving on to the step number 10, where we save our aggregated data and export our charts so we can use them later. So first I will be saving the aggregated data, which means the CSV files, separately. So I will be saving the sales per product, sales per region, and monthly sales. So sales per product dot to CSV, and here I will be copying the path where I want to save it, and I am writing R, and inside of the inverted commas I will be pasting that path, and I want to sales here by name, sales by product. And if I run this program, I will be basically displayed for these 4 figures. And here, as you can see, inside of the directory I have got this file sales by product, and if I open it, here the data saved in this CSV file. So since I have to save 3 files basically, so I will be just copying the first line and will be pasting here, and I'm going to just change the name here. So this is going to be sales per product, sales per region, and monthly sales. So just change the name for the saving aggregated data. And then we will be moving on to saving a chart as an image. So I will be basically copying this bar chart and simply paste it over here, and I will be simply writing here plt.savefig, and simply I will be copying this path over here and paste the path over here, and I will simply change the name here, bar chart sales by product.png. And if I run this program, I will be displayed again 4 images, or you can say 4 figures. This is the fourth, and inside of the directory, this monthly sales, sales by product, sales by region, and this bar chart has been saved. So that's it for this tutorial guys, where we have learned how to create a complete sales analysis dashboard with Python. And if you find this video helpful, then please hit the like button and subscribe to my channel. Thanks for watching.